In this section, we're going to talk about a complex fraction. And a complex fraction is kind of like, I call it a big fraction where you have little fractions inside it. So if you look at this fraction here, notice the line here, it kind of separates and creates the big fraction. And then if you look in the numerator above this line, you'll have a couple of fractions here, 1 over x and 1 over y. And then in the denominator, which is below this big line, you have another fraction in the denominator, 1 over xy. So one of the easiest ways to simplify these is to get rid of these smaller fractions is to just multiply each term in the fraction by the lowest common denominator of all the fractions. So if you look at this fraction, the denominator is x, this fraction, the denominator is y, and this fraction, the denominator is xy. So the lowest common denominator would simply be xy, because x will divide into xy, y will divide into xy, and certainly xy will divide into xy. So what we're going to do here is we're going to multiply the fractions in the numerator by xy and the fractions in the denominator by xy. Now when we multiply the fractions by the numerator, 1 over x times xy, that's going to be xy over x. And so the x will cancel there, and then we'll just have y. So we get y here. Alright, and then when we distribute the 1 over y times xy, then the y's cancel, and we just get x. So we get y plus x. Now in the denominator of the big fraction, we're going to take xy times 1 over xy, and in that case, the xy's will cancel, and you just get 1 for when you multiply 1 over xy by xy, you just get 1. So in the denominator, we get 1. So in the numerator, we get y plus x. Well, I'll just write that as x plus y all over 1, and x plus y divided by 1 is simply x plus y. So anyway, that's the general idea. Let's do a couple more examples here. Okay, so in this example, the little fractions 1 over x, 1 over y have a common denominator of xy. So since we have the same fractions down here, just a different sign, the lowest common denominator would be xy. So basically I'm going to multiply xy times each of these 4 terms. So I'm going to multiply xy times 1 over x, and so kind of like what I did a minute ago, the x's will cancel, and that'll give me y. And then multiply xy by 1 over y, and the y's will cancel, that'll give me x. And then in the denominator, the same thing's going to happen. 1 over x times xy is just going to give me y, and 1 over y times xy is just going to give me x. But I have a minus, so that's going to be y plus x over y minus x. In the y plus x in the numerator, y minus x in the denominator. Now for this one, these whole numbers 2 and 3, remember their denominator can be thought of as 1. So, and remember 1 will divide into anything. So really I just need to find the lowest common denominator that x and x squared will divide into, since that's what I have in my other denominators. Okay, so the smallest power of x that both x and x squared will go into would be x squared. So now I want to multiply each one of these terms in the numerator by x squared, and then multiply each term in the denominator by x squared. And that will eliminate these fractions that I have. And here's why. If you say 2 times x squared, you're going to get 2x squared. But if you multiply 11x squared, 11 over x times x squared, well, the x in the denominator of this fraction will cancel with one of the x's here and just give me 11x. So that's just going to be minus 11x. And then here, 15 over x squared times x squared, the x squared in the numerator cancels with the x squared in the denominator, and I just get 15. So that's 15. And then similarly on the bottom, 3 times x squared is 3x squared, and here the x in the denominator of that cancels into the x squared, giving me x. So I have minus 5x. And then here the x squared in the numerator cancels with the x squared in this denominator, and so that's just going to give me minus 12. And now I have 2x squared minus 11x plus 15 over 3x squared minus 5x minus 12. Now again, remember, we always want to see if these can be simplified further. So I went ahead and found the factors of the numerator and found that it factors into 2x minus 5 and x minus 3. And it turns out the denominator factors into 3x plus 4 times x minus 3. And since I have a common factor here of x minus 3 that can cancel, because x minus 3 over x minus 3 is 1, then the answer is just going to be 2x minus 5 over 3x plus 4. Okay, we'll do a couple more here. On this one, since the 2x, the 1, the 3x, and the 8 all have denominators of 1, all I really need is a common denominator for the x plus 4 here and the x plus 4 here. So that would just be x plus 4. So the lowest common denominator here would be x plus 4. So what I need to do is I need to multiply the 2x by x plus 4, the minus 1 by x plus 4, and then this fraction 7 over x plus 4 times x plus 4. And then in the denominator I multiply the 3x times x plus 4, the minus 8 times x plus 4, and the 17 over x plus 4 times x plus 4. So you can see here I've shown you what I'm going to do. 2x times x plus 4 minus 1 times x plus 4 plus this fraction over x plus 4. Now what's interesting is when I multiply 7 over x plus 4 times x plus 4, well, since x plus 4 over x plus 4 is 1, that's just going to be 7. So that's just going to turn out to be 7. And then down here I take 3x times x plus 4 minus 8 times x plus 4, and then when I multiply this fraction by x plus 4, I get, again, just the number in the numerator, 17. Now let's go ahead and do this. 2x times x plus 4. Now remember, you can't cancel these x plus 4s. That defeats the whole purpose of doing what we're doing. So we have to multiply this. 2x times x plus 4 would be 2x squared. 2x times 4 would be 8x. Minus 1 times x is minus x. And then minus 1 times 4 is minus 4. And then bring down the plus 7. And then here, 3x times x plus 4, 3x times x is 3x squared, 3x times 4 is 12x, minus 8 times x is minus 8x, minus 8 times 4 is minus 32, and then bring down the plus 17. Now, in combined like terms, we know that 8x minus x is 7x, and we know that minus 4 plus 7 is 3, so this would equal 2x squared plus 7x plus 3. Do the same thing on the bottom. We know that 12x minus 8x is 4x, and minus 13 plus 17 is minus 15. So this is going to be 3x squared plus 4x minus 15. And then just like I did in the previous problem, see if the numerator and denominator will factor, and indeed they will. This factors into 2x plus 1 times x plus 3, and the denominator factors into 3x minus 5 times x plus 3. And then so the x plus 3 over x plus 3 is 1. And so your final answer would simply be 2x plus 1 over 3x minus 5. Okay, now the last one here, it's kind of different from the others. But notice here, I have a common denominator here of 3 minus x. So I'm not going to worry about this 3 for now. I'm just going to focus on this fraction right here. So I want to eliminate the fraction here, the 3 over 3 minus x. So one way to do that, since the lowest common denominator is 3 minus x, I can multiply the numerator, which is 3 times 3 minus x, and then I can multiply the entire denominator, which is 3 minus 3 over 3 minus x. See, here it is again. I'm going to multiply that by 3 minus x. Now this part's easy. 3 times 3 is 9. 3 times minus x is minus 3x. And then here, I do the same thing. 3 times 3 minus x is going to be 9 minus 3x. But when I multiply 3 over 3 minus x times 3 minus x, that cancels, and so I get another 3, or actually another minus 3. So anyway, the 9 minus 3x, that came from when I multiplied the 3 times 3 minus x. And then the other minus 3 comes from when I multiply this fraction by 3 minus x. Okay, now simplify the fraction. Let's see, I have 9 minus 3x, and then here 9 minus 3 is 6, so that would be 6 minus 3x. So I have and don't forget we're carrying the 3 along, this 3 that we're carrying along. We'll get to it in a minute. Okay, so we have 3 minus 9 minus 3x over 6 minus 3x. Now I'm going to let the common denominator be 6 minus 3x. I actually could simplify that a little bit, but I don't want to do that right now. I'll do that at the end. So if you look at now, I have this fraction, which has a denominator of 6 minus 3x. And then I have this fraction, which as a fraction would simply be 3 over 1. So all I need to do is figure out a way to make 3 over 1 have a denominator of 6 minus 3x. And I can do that by just multiplying 3 by 6 minus 3x over 6 minus 3x. And then when I do that, 3 times 6 is 18. 3 times minus 3x is minus 9x. And then I have to subtract. Now I did the distributive property in my head here, so that's going to be minus 9. And then minus negative 3x, which is 3x. And since I now have the same denominator for both, see, that's what allows me to combine those, and the denominator is 6 minus 3x. Okay, let's wrap this up. 18 minus 9 is 9, and minus 9x plus 3x is minus 6x. So what I have here is 9 minus 6x over 6 minus 3x. And I went ahead and factored out the common factor of 3 here. And when I factor a 3 out of here, I get 3 minus x. And I factored a 2 out of the denominator, and I get 2 times 3 minus 2x. I did that to see if possibly there would be a common factor in the numerator or denominator. So I see there actually is none. So therefore, I can leave the answer like this. You know, I went ahead and showed you another thing you could do just in case you're trying to find the answer, and like say you're looking in the back of the book for the answer or something and you're not finding one that matches. Another option here would be you could factor a negative 3 out of the top, and if you do that you would be left with an x minus 3 in the numerator. And you could factor a negative 2 out of the denominator, and that would leave you with a 2x minus 3 as the other factor. And then, you know, when you have a negative 3 divided by a negative 2, that's the same as a positive 3 divided by a positive 2. So basically the negatives cancel. And so you could write that as 3 times x minus 3 over 2 times x minus 3. So, you know, I really wouldn't lose a lot of sleep over whether you write it like this or whether you write it like I wrote over here. But both of those are really correct answers. Okay, so that finishes the section on complex fractions. I've got another section I want to talk about here that deals with solving rational equations. And so we'll talk about solving rational equations in the next video.